There are two-digit numbers that satisfy the following. Each number has the same digits. So when we're talking about two-digit numbers, we're talking about something like 34 or 43. And wherever it says the same digits, that means that they have the same two numbers. They're just reversed. So 34, 43, 12, 21. This is what two-digit numbers and meaning the same digits represents. The sum of the digits in each number is 10. The difference between the two numbers is 54. This is what we're trying to figure out. Part A says the numbers 58 and 85 are two-digit numbers that have the same digits, and the sum of the digits of each number is 13. Find two-digit numbers such that the sum of the digits is 10 and both numbers have the same digits, 64. So switch 64 around, that would be 46. Now let's think of all of the two-digit numbers that would have a sum of 10. That would be 19 and 91, 28 and 82. Think about it. Just 1 plus 9, 2 plus 8, 3 plus 7, 4 plus 6, and then 5 plus 5. Okay. So there are 9 two-digit numbers, because if you think about it, 1, 2, 3, 4, 5, 6, 7, 8, and then 55, which is its reverse of itself. What is the difference of the two-digit numbers from part A? So in other words, what's the difference between 64 and 46? Well, 64 minus 46 is going to give us 18. Well, let's look at the difference between all of these sets. Okay, I'm just going to subtract them. Basically, 91 minus 19, the difference is going to be 72. 82 and 28, the difference is going to be 54. 73 and 37, the difference is going to be 36. 64 and 46, as we already said, the difference is 18. If I did 55 and 55, the difference would be 0. So we're looking for that pair that has the difference of 54. That would be your 28 and 82. Now we can switch this up to have, instead of two digits that equal 10, now let's have a sum of 12. So if we have to have a sum of 12, if we think about 1 plus 11, 2 plus 10, well, notice this would cause us to have 3 digits, so we can't include those. But we can include 3 and 9, 4 and 8, 5 and 7, 6 and 6. So that would be 39 and 93, 48 and 84, 57 and 75, and then 66. And then we find their difference. So the difference between 39 and 93 is going to be 54. The difference between 84 and 48 is going to be 36. The difference between 75 and 57 is going to be 18. 66 and 66 would be 0. So we want the sum of 12, the difference of 54. That's going to be this one right here, 39 and 93. Let's go ahead and look at, suppose you have a supply of red, blue, green, and yellow tiles. What is the fewest number of different colors needed to form a 3x3 square of tiles so that no tile touches another tile of the same color at any point? Now, at any point is very important. It doesn't say at any side, it says at any point. So we have this possible arrangement, and it asks us why this square arrangement of tiles shown here is not a correct solution. Well, if you look at this and we take into account, notice that the yellow tiles are touching each other at those corners. The green tiles don't touch each other. There's only one red tile, but the yellow tiles are touching each other at their corners. And that's why this at any point is very important. So one plan is to choose a tile for the center of the grid and then place others around it so that no two tiles of the same color touch. Why must the center tile be different color from the other 8 tiles? Well, let's think about it. The center tile right here, so in other words, this center tile right here is actually touching all of the other 8 tiles. So it's going to touch everything. So each of the other 8 tiles touches the center tile at one or more points, because the corner tiles touch at those points here, and then these other 4 touch along these sides. Suppose that you put a blue tile in the center and a red tile in each of the corners, like shown here. What is the smallest number of different colored tiles needed for the remaining openings? So remember, if I put the same color in these 2, they're touching right here. And so I can't use the same color there. That would mean I would have to use a green here and let's say a yellow or something. Well, if I use a yellow here, I can't use a yellow here, so I'd have to go back to my green here, which is okay because it's not touching that green. And if I use the green here, I can't use a green here, so I'd have to use the yellow over here. So for the remaining openings, I would have to use 2 more colors, and they would have to be on the opposite sides for them not to touch at any point. Suppose the problem had asked that the smallest number of colors to form a square of 9 tiles so that no tile touches another tile of the same color along an entire edge. So this changes us. So let's think about, here I have 9 tiles, and all it's saying is I can't touch along these edges. It doesn't say anything about the actual points, okay? It's just saying along those edges. So that means that if I want to put, let's say, a blue here, well, I couldn't put it here because it would touch here. And I couldn't put it here because it would touch here. But I can put it here because it doesn't matter if it touches on the corners. And I can put it here because, again, it doesn't matter if it touches on the corners. And I can put it here, and I can put it here. And then I can put a second color here, 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 and here. Because the reds are not touching along the long edges, entire edges. They touch at the corners, but they don't touch along the entire edges. So the smallest number of color tiles needed would be 2.